So here's a third example, which is actually slightly trickier than others. So this is maybe an exam style question. Two spheres P and Q of equal mass collide at the same speed u along a shared horizontal axis. P is angled at alpha to the horizontal, and Q is angled at alpha to the vertical. Given that Q moves off parallel to the j-axis, show that E equals tan alpha minus 1 over tan alpha plus 1. So this is a fairly tricky example, so go ahead and try it if you can, and when you're ready, or if you get stuck, come back for the solution. So here's the solution. We start with the principle of conservation of linear momentum. So mu cos alpha plus m times minus u sine alpha, because we're taking alpha in a different direction here. This is alpha to the vertical instead of the horizontal. Is mv1 plus m by 0, because again, traveling parallel to the j-axis means that it's hitting off completely vertically. So therefore v1 is u cos alpha minus u sine alpha. Now if we go to Newton's law of restitution, we get that v1, again, is minus e times u cos alpha plus u sine alpha, because of these two negatives here. So we get u cos alpha plus u sine alpha. So in order to get e here, we substitute in our value for v1, which is u cos alpha minus u sine alpha, divided by u cos alpha plus u sine alpha, equals minus e. Now, flipping everything around, we get u sine alpha minus u cos alpha over u sine alpha plus u cos alpha equals e. So we can cancel all the u terms. So all the u's cancel. Now, in order to get it into tan, if we divide everything by cos alpha, using the fact that sine theta over cos theta is tan theta, we get that it's tan alpha minus, well, cos alpha is 1, so we get tan alpha minus 1 over tan alpha plus 1, which is exactly what we were required to show.